So this is the lab. All right, in this lab, you have 4 activities, okay? So the first 2 activities are the reading activities. Basically, they are the refresher for your introduction to programming course. So in the first activity, you're gonna be refreshing your memory about the flowcharts, use of flowchart in programming. Basically, what are the flowcharts, and when you want to program, when is the time to start drawing a flowchart, and how you draw the flowchart, what are the main components of the flowcharts, and how you map your program into a flowchart. So you click on this link. In case you forgot all about flowchart from your introduction to your programming, you come in here, take a look at these symbols. Can you guys see this page? This page is Tutorial Points website. Am I sharing the right page right now?
Yeah, sure.
Okay, so these are the symbols that you use in your flowchart. Basically, when you want to program, you have to plan it, okay? You will plan your program, and then you represent your program using this graphical interface. So you can take a look at this, and in case you forgot, and see how you basically use different symbols to draw a flowchart for yourself. For example, this flowchart is for calculating the average of 2 numbers. You take 2 numbers from the keyboards, that's the starting point. Take number 1 and number 2, then the average gonna be the processing block of your program. You add number 1 and divide it by 2, you obtain the average, and then print the average on the screen and end your program. So this is a simple flowchart for calculating the average of 2 numbers. So this is example number 2, so you can go through that. These are not difficult, they're just a refresher for you guys. So you don't need to submit anything regarding activity 2.1 and activity 2.2. So when you write your report, just you need to divide your report based on the activity that you've done. So for example, for activity 2.1, you're going to be saying that, okay, you done this activity, basically read the concept of flowchart and the use of flowchart in programming. And whatever you learned from it, you're just going to be reflecting under this section in your report. It may be 3 to 4 lines of words, or it could be just one simple paragraph. So it's not something that you need to write like 1 page of description of what you did. And activity 2.2 is the same. In here, you also learn about flowchart and pseudocode. So as you progress in your programming in different languages, at some point of time, you will see that you may not need to draw flowchart for your program. Pseudocode might be enough for you. So pseudocode also has the same, use as flowchart. It tells you how to plan basically your program. So pseudocode is similar to computer code, but also it's very close to English language. So what you want to do, you basically express it in English language, but it is somehow also near to like one high-level programming languages. So this is an example of flowchart in here. So basically the steps for your program are listed in here in a plain English language. For example, here you have to repeat the following. So in programming, you can do this, implement basically this line by using a for loop or while loop. And these are the initialization steps. And this is the end of your program. So basically, this is pseudocode. Some people like add line number to their pseudocode, but you don't need to do that. But indentation is good. If you can have some indentation in your pseudocode, that's going to be useful. So take a look at this pseudocode and the program that this has been described over here to get some idea how to write a pseudocode. Pseudocode always are useful when you are doing programming. So you need to know what you want to do for that program and write it down so that when you want to use a specific program like C, C++, or assembly, you have the framework of what you plan to do. And then you take the syntax from cheat sheet and implement those lines in the program of your choosing. And in this case, for this lab is C, but throughout the course, you're going to be using C and assembly in combination somehow. So once I've gone through to those websites and learned about the flowchart and pseudocode, then you come to activity number 2.3. In activity number 2.3, what you need to do is just take two numbers using a scanf syntax in C, and then do this operation on those two numbers, logical or logical and, bitwise or bitwise and, multiplication and comparison. A brief explanation about this. So logical or and logical and basically you and or two integer numbers and the resulting value going to be true or false. So based on that, you're going to be printing 1 or 0 on the screen. So these are the logical or and, logical and. But bitwise or bitwise and basically converts, C automatically going to convert these integer numbers into 0 and 1, and then going to be doing the bitwise or and on these two inputs. And then based on the result, then it's going to print out that onto the screen. So the first two operations are logical. So the thing that you're going to be printing out going to be 0 and 1, representing false and true. But for the bitwise, again, it's going to print an integer number. So section E is just multiplication. You take A and B, then you multiply them together, you get number, for example, C. So you need to declare C at the beginning of your program as an integer. For example, integer C is this, or integer C is equal to A multiplied by B. And then you use the printf to print that out. What you need to do for comparison? For comparison, you take two numbers from inputs, right? For example, number A is 2, number B is 5. Then what you need to do is that you take these two, you compare if like A is greater than B, you say input 1 is greater than input 2. Or you simply say 5 is greater than 2. So using printf function, these are easy to implement. So how you implement comparison? Using if statement. Using if statement, you simply can implement the comparison. For example, you say, if A greater than B, print F A greater than B, and else B greater than A. So this is very simple. Don't take it. It's not something very technical. These are just refresher for your C programming. These are very simple. Okay, the next thing after you wrote your program is to compile it. How you want to compile it in Linux. So I guess we have done one of these examples before during the past lab when we compile a simple Hello World program. You use GCC. So in your Linux, after you write your file, so I ask here to name your file as lab21c. So the name of the file that implement this program is lab21c. So assuming that you are in the same directory as your file, then this is the command that you enter to produce the binary or executable for your C code. So here the command says, okay, GCC, create for me the binary file for lab2c and name it -o means the output file should be lab21.out. So this is the output, or this is the binary file generated by a compiler from your source code lab21c. So after generating this file, or executable file, or binary file, then how do you run it? You run it simply by typing this /lab21.out. If you just remember that you have to be as the same directory as your file. If you're in the different directory and you type this command, it says that the file cannot be found. So make sure of that. These are pretty straightforward. If you are using the virtual machine in Canvas, GCC is installed over there for you. If you are using your own personal computer, then you need to install GCC. Basically, the system tells you how to install GCC. If you type this command, right, and GCC is installed on your system, it's gonna get through and generate the file for you. But if GCC is not there, Linux will tell you, okay, GCC is not installed. And it also tells you what command to use to install GCC. So it's like sudo install, sudo apt-get install GCC. As simple as that. So once you type that, then the GCC is going to be installed on your system, and then you can simply use it. Okay, activity 2.4 is to write a C program that takes two numbers from the keyboard and say whether they are co-prime or not. I guess you guys know what co-prime numbers are. Okay, let me go back to chat. Yeah, I guess some question in the chat. Okay, Ivan has asked me questions regarding the Vim, that he couldn't install Vim on his machine. Once I come to your chat room, I'm going to be explaining that how you can install Vim on your system. Unfortunately, VirtualBox is not very stable, and sometimes, depending on your hardware and platform, it complains when you're going to install something. Most of the platform and hardware, 95% of them are okay. 5% of the hardware and platform, you're going to have a bit of problem with VirtualBox. That's the reason I'm telling you guys to, the recommendation that I have is to just use the virtual lab. Don't go and take all this headache for you. Just go there in virtual lab, everything is there ready and it's paid by us. So you shouldn't be worried or even, waste your time if your VirtualBox gives you any headache. Just go to the virtual lab in Canvas page and do your programming. So the conclusion is that if you kind of having multiple issues with if your VirtualBox works fine, your Linux works fine, and you've installed Vim and everything is great, okay, go ahead and use your own personal setup. But if you see that you're getting lots of error and it's kind of like lots of headache, you get frustrated, don't waste your time. So we solved that issue by introducing the virtual lab. But anyway, in this today lab, I'm gonna come and talk to each of you individually about your setting and the problem you have and my recommendation to solve those issues. Okay, let me resume share. All right. Okay, going back to lab. So lab 4 is, activity 2.4 in lab 2 is about writing a program that takes two numbers from inputs and tells whether they are co-prime or not. Basically, you do some calculation to understand that. For example, you take 5, you take 7, and doing your process, and at the end of your program, you print out a message saying that 7 and 5 are co-prime. Why is that? Because they don't have any common divisor that are greater than 1. So 7 and 5 is an example of co-prime number. So let's take two other numbers as an example. 6 and 3. Are they co-prime or they are not? So 6 and 3, if you start dividing 6 by numbers less than itself, you divide 6 by 1, you get 6. You divide 6 by 2, you get 3. You divide 6 by 3, you get 2. And then 6 by 4 is going to be fractional numbers. So these are 1, 2, 3 are the divisor of 6. Now let's find the divisor for 3. You basically 1 is one of the divisor, 2 is not, because you get remainder when you try to divide 3 by 2, you get 1, and then it's going to be remainder going to be 1. Therefore 2 is not the divisor for 3. And then the last number gonna be 3. You divide 3 by 3, and then you get value of 1, and the remainder is 1. So for 3, the divisors are 1 and 3. For 6, the divisors are 1, 2, 3, and 6 itself. Therefore, you can see that 3 is common between 6 and 3. Therefore, since their divisor is the greatest common divisor, which is 3, is greater than 1, they are not co-prime. So this is a simple example in case you forgot that. So in your program, the simplest way to calculate that is you start like dividing the numbers, the integer number by integer number less than itself. You're going to be creating an array. And then for the second number, you can also create that array and then search in the array and see if you can find something that's common between these two arrays and is greater than 1, then you can say that they are not co-prime. So this is as simple as that. There are different kind of, algorithm to understand the co-prime number, how the numbers are co-prime. So there are different algorithms that depend on the complexity and the time taken. So at this point, I don't care about the time complexity. I don't care about the complexity of the program at all. So as long as you get the correct answer at the end of your program, it will be fine. So what are the deliverables? The deliverables are basically your lab report. And so go to your lab report. It tells you, okay, you need to have the screenshot of the output for your activity 2.3, the flowchart you need to have in your lab report, then the pseudocode of the activity 2.4, and a screenshot of the output in activity 2.4. So basically, you need the pseudocode for your two program, so that you can, for example, lab 2.1c, lab 2.2c. So these two files you need to upload. And then you have your lab report when you explain about different activity, 1, 2, 3, and 4. And for each activity, if there is a screenshot of the output of the program, you need to include it in your lab report. So that's pretty much it for your lab report. Please try not to missing the cover page, because in the cover page you're gonna be listing the name of your team member, so that if your reports are the same, it's not counted as plagiarism and it's counted as a collaboration work, so that I know. So each individual need to submit its own lab report. All right, so this is the end of lab 2 description.